Everyone is building AI agents right now. Demos are everywhere, prototypes on GitHub, even proof of concepts on Twitter. But here is the problem. Almost none of them are production ready. Only 5% work in production reliably, 95% fail in production demos only. I just read a research paper on designing, developing, and deploying production grade agentic workflows, and it completely changed how I think about building this system. Not toys, not demos, actual production system that works when real users depend on them. Let me show you what real engineering looks like. First, let's understand what changed. So in traditional AI, it was simple, like you give a prompt, AI model will just return you the response. But in Agentic AI, it's completely different. These systems can plan, call tools, validate their own result, and even retry when they fail. And they can coordinate with other agents, and they can easily operate with minimal human intervention. This isn't about writing better prompts. This is about designing AI system and not AI demos. And that requires actual software engineering disciplines. Here is a key insight from the research. Stop building monolithic AI application and start building agentic workflows. So, in an agentic workflow, each agent has specific role, multiple agents collaborate, and reasoning, validation, and execution are completely separated. Let me show you what this looks like in practice. So a user comes in, the planning agent breaks it down into tasks. The orchestrator distributes works to specialized agents. Each agent does one thing well. Finally, a consolidation agent brings everything together. This modularity is what makes system reliable and scalable. The first principle is simple but powerful. One agent should have one responsibility. When you overload agents, making them plan, execute, validate, format, log prompts become complex, behavior becomes non-deterministic, and even debugging becomes a nightmare. So instead, we should split this responsibility. Each agent ideally use a single tool and produce a predictable outputs. This is just classic software engineering applied to AI. And here is something that might surprise you. Agents don't need to be smarter. They need better tools. The reliability of agents depends on deterministic tool that work the same way every time. Clear input, output, one track so that there is no confusion. Reduce ambiguity is what the agent can and cannot do. Your agent is only as good as the tools and boundaries you give it. Throwing more intelligence at a poorly designed system doesn't fix it. This one important. Not everything needs AI. You don't need to use AI everywhere, right? If a task is deterministic, like writing files, calling APIs, database operation, generating timestamp, don't ask an LLM to reason about it, right? Move this task into pure functions. Keep AI only where reasoning is actually required. This reduces cost, latency, point of failure, and even unpredictable behavior of the agents. It's about using the right tool for the job. So if you closely look at this diagram, so this is how you can decide if there is a task to accomplish. So you can think like if it is a deterministic, then you can just use a pure function. You don't need AI because you don't need reasoning there, right? If vice versa, then you can go, if reasoning required, you can use AI agent LLMs. So Also, there is another principle that I like is that single model can sometimes hallucinate and they can drift, they can introduce biasness. So here is a powerful pattern from the research that using multiple models to generate outputs, then use a reasoning agent to consolidate and validate them. This improves accuracy, reduce biasness, and aligns better with the responsible AI practices. Responsible AI isn't just about picking the right model, it's a system design problem. And here are like some benefits of multi-model approach. If you're going with the single model, then it will hallucinate, it will have biasness, and it will also have a single point of failure. But in multi-modal and plus reasoning, you improve the accuracy, you reduce the biasness, you also do cross validation, and this also adhere to the responsible AI practices. Finally, let's talk about production readiness. Because agentic AI system are production system, they don't need to be treated that way. That means containerized deployment, Kubernetes orchestration, logging, monitoring, retries, error handling, secure tool access, version plumb, and workflows. Without this, your agentic system are just fragile prototype. They will work in demos and fail in production. One last critical reminder from the paper was we should keep it simple. So the complexity kills agentic system. Over engineering leads to hidden behaviors, hard to trace failures, and unmaintainable workflows. So simple, flat, and function-driven design works best, especially when LLMs are involved. If you follow the KISS principle, which is nothing but keep it simple, stupid. Can this be simpler? Yes, you should simplify it and reduce the complexity. So now let's put all the principle together and see the view how it's. So if you want to build a production grade application, a agentic AI application, you should have one agent, one responsibility. You should use tool instead of relying on the intelligence of the LLM, and you should only use LLMs where it's needed, where reasoning is needed, and using multi-model will reduce the biasness and hallucination. Then you can take the response from the multi-model and have a reasoning agent and then consolidate the responses. And agentic AI's applications are something that needs a production infrastructure like Kubernetes cluster, logging, monitoring, and everything. And last but not the least, keep it simple. Don't introduce complexities where it's not needed. So agentic AI isn't magic, it's actually a system design problem. Models will keep improving, but without good engineering discipline, agentic workflow will remain fragile and hard to maintain. The real leverage comes from how we compose agent tools, workflows, and not from chasing the latest model. I have linked the full research paper in the description. If you're serious about building agentic AI system that work in production, it's worth reading. I will keep sharing learnings as I apply these ideas to real system. If you found this useful, please subscribe for more deep dives on AI system architecture. Thanks for watching.